Last time we were calculating volume integrals, and we had this idea about taking a region and cutting it into slabs. Each of those slabs has some amount of volume associated to it. And from there, we can build a Riemann sum, only to find that, yet again, the answer is an integral. The Riemann sum is an approximation of the volume, and as we take more and more slices, my approximation gets better. In the limit, as the number of slices goes to infinity, we end up with an integral. Now, this isn't the only way to carve up an area. We ended up focusing on my cylindrical slices, my solid cylinders, for the example at the end of my previous lecture. Section 7.3 focuses on cylindrical shells. So this is a different way to build up volume. Now, this technique is different. The reason why we'll want to use it is because this cylindrical shell method, or just shell method for short, will let us find volumes that we actually could not have done using my slicing technique from the previous lecture. So here is an example of a harder problem. We're going to take the blue region here that is bounded by y equals 2x squared minus x cubed and the x-axis. So here I've got this sort of lump sitting on the x-axis, and I'm going to rotate it not about the x-axis, but this time I'm going to rotate it about the y-axis. Imagine sending this thing around on a pottery wheel and seeing what kind of a volume you would get. So that's a very intuitive idea, and a lot of shapes can be built up in that way, putting some flat region on a pottery wheel and spinning it around, see what you get. But I can't do my slices on the x-axis. One of my problems from last time looked at integrating on the y-axis. Maybe I could try that here. Well, if I did that, here in the picture, my pink rectangle is representing a slice, and a slice of width, let's call it delta y. I need to know the width of this slice. What is the y, what is the x coordinate on the left? And what is the x coordinate on the right? Well, the only formula I've been given is y equals 2x squared minus x cubed. It's not immediately obvious how I will find those two x coordinates. I could set up the algebra, but I don't want to. Not to be facetious. I can find this in a much easier way if I change my geometric picture. It will require a little bit more heavy lifting in my picture, but with the formula in place, then I can actually avoid my algebraic calculation that I would have had to do using the washer technique instead. Let's take a look at it.